which one has a greater rotational speed? So people who are not in pre-cal, 2 pi is the same thing as 360 degrees. And this is the rate at which the angle is changing. Thumbs up when you have a guess. Have a conversation. Okay. Let me ask the follow-up question before we hash this out. So same scenario. Which one has a greater speed? Just like your speedometer. And there's some equations to help guide your thinking. I've not answered either question.
I mean, I feel like you have to.
Correct answer. Okay, so let's everybody got something? Okay, going back to the original question. Which one has a greater rotational speed? Blue, green, the same. Is everybody okay with not C?
Yeah.
And we can determine it. Blue, green are the same. Got 2 votes for the same, 3 votes for the same. It is the same. You're going, both are going 360 degrees in the same amount of time. You okay with that? Okay. The rate at which their angle is changing is the same. Okay. So, which one has a greater speed? Blue, green are the same. 2 votes for green. If you're running track and there's no staggered start, you're just both starting the same. Which lane do you want? The inside or the outside? Inside. Why? Less distance. Well, in this race, they tie. Ready to go. And stop. So in order for the green to win, in order for the green to tie, but runs a greater distance, what does that have to mean about the green's speed? Has to be going faster. You okay with that? Okay. So, many of you learned something in that 3-minute conversation. Probably escribe. Something muy importante. Good? Okay, something, you learned something, capture that. Okay, the distinction between rotational speed and just regular speed. Okay. So here, this is circumference divided by the period. So there's a distance involved here. This is rotational speed times the radius. They had the same rotational speed, but the green had a greater radius. Good with that? Next question. Tell your neighbor and tell them why.
Yes. It's changing.
Oh, yeah. It's not accelerating, but it's at a constant speed, it's not accelerating.
That's five-ish.
It should.
Correct answer is? Correct answer is A. Speed communicates two things, speed and direction. If you change either one of those two, you have acceleration. Okay, good with that? Okay, which is known as centripetal acceleration. Okay. So centripetal acceleration speaks to how quickly you're changing your velocity towards the center of the circle. Okay, so if I'm walking in a circle, the direction I'm moving is the way my nose is pointing. So as I go in a circle, how quickly this velocity vector changes its direction towards the center of the circle, that speaks to centripetal acceleration, is how quickly this is happening. I'm not changing the magnitude of my speed, I'm just changing the direction of my speed, of my velocity. You okay with that? Okay. So, so just like we talked about last semester, if you have an unbalanced force, that causes acceleration. If you have a centripetal force, that's going to cause centripetal acceleration. Okay? Just like the force causes acceleration, and therefore the force is always in the same direction as acceleration, the centripetal acceleration is always in the same direction as the centripetal force, which is which way? Which way is centripetal force always pointing? Inward, towards the center of the circle. Good with that? Good? Tell your neighbor what you think. Correct answer is? Okay. The center of this circular path is like right here. That make sense? Like it isn't a full circle, but you pretend it is. Center is that, points towards the center of the circle, C. there. A question came up first hour, which I thought was excellent. Is it possible, like, what happens if it's speeding up and turning? That is definitely possible, happens all the time. In this class, we're gonna simplify that to say we're either speeding up or slowing down, or we're moving at a constant speed and in a circular path. Combining those two is for second year physics. Okay, good with that? So we're gonna move in, for this unit, we're all moving at a constant speed. Okay? Thumbs up when you have a guess. Conversation?
Doesn't green have a higher both?
No, they're the same buildings.
Well, green has, I was looking at B squared. Green has a bigger acceleration.
It has the same buildings as the B3.
Yeah, so I think it's.
No. Is it green?
Usually, yeah.
Cool.
So, what do you say? I like B. I like green. Okay? This, a little fuzzy. You know green's going faster, but it also has a bigger radius. But it's squared. But you see the fuzzy, like, you might be right. This one is definitive. Because you know both the green and the blue both have the same rotational speed, but the green definitely has a bigger radius. Does that make sense? You see that how this is fuzzy, this is like solid. Okay. So green has a greater centripetal acceleration. Okay. All right. How fast can a 400 kilogram car take a non-banked circular entrance ramp at a radius of curvature of 20 meters before it starts to skid while moving at a constant speed if the coefficient of static friction is 0.54, the coefficient of kinetic friction is 0.43 between the tires of the road. Okay. Non-banked, what does that mean? So a banked curve is one that, like, if here's the backside of your car, it's banked. Like most, like here's your license plate, most entrance ramps and exit ramps are banked. Make sense? Okay. Non-banked is you're on a horizontal surface. Okay. So here's the back of your car. Okay. License plate. Free body diagram. What forces are acting on it? normal force, gravity, and need one more. Friction acting which way?
About 15 minutes today.
Good deal. Friction acting towards the center of the circle. Yes? Does that make sense? Towards the center of the circle. Okay. If you didn't have friction, which way would it slide? Like, right? You need friction, gripping between the tires and the road. And is it going to be static or kinetic? Friction. We are not slipping or sliding. We're gripping. We want grippage. So we're going to have static friction. We really want the maximum static friction because like right before it starts to slide. Good with that? Okay. So here's your free body diagram. Here's a really important aspect. Always make towards the center of the circle the positive direction. Always. Okay? So I'm going to make to the right positive x and up positive y. Sum of the force in the x direction, are they equal to 0? Is he doing what inertia wants to do? It's not experiencing acceleration. Sum of the force in the y direction, are they equal to 0? Yes, it's at rest in the y direction. Okay? Woo! Yeah? It's been a while. Okay? So I've got maximum static friction is equal to mass times centripetal acceleration. And I've got normal force minus gravity is equal to 0. Okay with that? Okay. I'm going to do some crazy stuff here. Ready for this? All right, so a lot of times we know that centripetal acceleration is going to be equal to speed squared over the radius. I'm going to use, actually, I'm just going to do this. Mass is equal to, a lot of times you could just jump straight away to this. Mass times speed squared over the radius, unless I ask for acceleration explicitly. But usually I'm going to ask for speed or radius or something. Okay with that? Okay. Now, I also know, hey, I'm dealing with coefficients. I'm probably going to need to incorporate this equation. Remember that one? Okay. Now, I'm going to push you a little bit. I'm not going to make you do this. I'll give you enough information. But like as you get better in physics, you deal less and less with numbers. So check this out. I'm going to use that. I'm going to substitute that in here straight away. I'm going to coefficient of static friction times normal force. It's going to be equal to mass times speed squared over the radius. See what I'm doing there? I'm substituting rather than plugging in numbers. You can plug in numbers if you want, that's fine. Okay. Okay. Normal force. Where do I find normal force? Because I've got the mass. I'm looking for the speed. I've got the radius. I've got the coefficient. I need normal force. Where do I find normal force? Over here, right? So I know that normal force is going to be equal to my force of gravity, which force of gravity hey, that's equal to mass times 9.8, right? Which is equal to that. So I could go, oh, wait a minute. That's equal to this, which I can then like, boom. So, we have coefficient times mg is equal to mass times speed squared over the radius. How are we doing with that? I know that's wacky. Kind of throwing alphabet soup at you, but you see the order. Math people, what can I do to simplify? What does that mean? Car's massless? What does that mean? Doesn't matter. Mass doesn't matter. So I can go 0.54 times 9.8 equal to speed squared over the radius. And I just solved for that. I find that to be 10.3 meters per second. Okay? That is the hardest problem you're going to have to do for this unit.
So the kinetic friction coefficient, it was just there. Okay.
Yep. Good with that? Got a worksheet due tomorrow. I'll put the right one on Canvas.